Hello everyone, I am Harsh, and in this video I will explain you my project that I built recently. I will first show the demo, then I will explain the architecture and services that I use for building this project. Alright, this is AI powered financial planner. In this project we are analyzing the user's financial portfolio based on the real-time market data and provide detailed reports, charts and retirement projections by utilizing multiple AI agents. Alright, here's my web page. Now let's navigate to dashboard. Here the user can see his current portfolio value, and in this section the user can configure his retirement preferences including years until retirement and target retirement income annually along with target asset allocation and target regional allocation. Let's navigate to accounts page. Currently we have 3 accounts: brokerage account, Roth IRA account, 401k long-term account. In Indian context, it could be a zerodha account, EPF account or a mutual fund account also. Each account could have multiple positions. Positions are simply the quantities of stocks or ETFs that we own. Let's now navigate to next page and trigger our analysis. The analysis could take 20 to 30 seconds for completion. Meanwhile, let's understand our data model. Alright, user table is consist of user specific data and retirement goals. A user could have multiple accounts and account could have multiple positions. And here, instrument table represents the actual stock or ETFs with current price and allocation breakdown. A user could request for multiple jobs, and if we look closely to jobs table, it contains multiple JSON fields, and each of this JSON field will hold the output for a specific AI agent. Alright, here's our portfolio analysis result, and here's the complete breakdown of analysis. It explains the overall structure and current positioning of our portfolio along with the risk and diversification assessment. And it also contains the recommendations by our AI agents explaining the high-level actions to improve our portfolio. Alright, let's take a look at the charts made by our AI agent. Here it includes multiple visuals including the pie charts and bar charts according to our portfolio analysis. Let's move towards the retirement projection. It contains the retirement readiness assessment based on our portfolio and recommendations to improve success rate based on the Monte Carlo simulation performed by our AI agent. It also includes the risk mitigation strategies and actions to be taken with timelines. Alright, here's the architecture and the AWS services that I use for building this project. I will explain you the working of every agent one by one. Alright, my project is consisted of multiple AI agents that includes the researcher agent, the planner agent, the tagger classify agent, charter agent, reporter agent and retirement agent. And there are 2 separate databases. The one is Aurora DB and the second is S3 vectors to store the vector embeddings. The researcher agent performs the web research to find the current market trends. It uses the 𝗬𝗁 as a tool, and it also triggers the ingestion pipeline to store the web research in vector store as a vector embeddings. And here you can see the input and output structure for this AI agent. Alright, here's the planner agent. It coordinates all the agent and manages the job lifecycle. It could trigger multiple AI agents parallelly, and it could also use the Polygon API to fetch the real-time prices for the stocks. And here's the input and output structure. And here's the tagger agent. It classifies the financial instruments and generates allocation breakdowns for them. Here's the input and output structure for it. And here's the reporter agent. It generates the portfolio analysis with metrics and recommendations. And for context, it could retrieve the document from vector store. And here's the input and output structure for it. Here is the chart agent. It analyzes the portfolio and generates various visualizations. It generates visuals for asset allocation, account distribution, stock holdings, and geographic distributions. And here's the input and output for it. Here is the retirement agent, and it is the most complex agent of all. It runs 10,000 Monte Carlo simulations to project retirement outcomes at different withdrawal rates. It also calculates the portfolio value and asset allocations. Here's the input and output structure for it. Alright, here are some of the cost optimization strategies that I used for building this project. Firstly, I used the serverless architecture so that we don't pay for the idle infrastructure, we only pay when the system actually runs. And for vector search, I used the S3 based storage instead of open source and Pinecone. that reduces the cost by nearly 90%. Alright, here are some of the features that makes my project enterprise grade. Firstly, I implemented the authentication with 𝗀𝗏 and rate limiting with the help of API gateway. And I stored my database credentials in AWS Secret Manager. And for monitoring purpose, I used the Amazon CloudWatch and LangFuse for tracing. And here are some of the features that I did not implement it, but they are nice to have. It includes WAF, which is an application firewall for threat protection. And we could also implement guardrails for content filtering and moderation. And we could also implement a response size limit. And we could also implement explainability by adding an extra field in the parenting models of AI agents.